Section 7.1, we're taking a look in this chapter at decimals. Okay, so I kind of mentioned a couple times in chapter 6, there might be a tendency for you to say, well, this works because if I change these into decimals, I can do X, Y, Z. And I was like, we haven't really talked about decimals yet, right? So we're going to talk about decimals in this section. And first, a little bit of vocabulary. A decimal comes from the Latin word meaning 10. Okay, so it means 10. And the reason that we use that phrase is because of this DEC at the beginning, right? That prefix means 10, base 10. And we have a base 10 number. We have 10 numerals. Our numerals actually don't include the number 10 because that's a 2-digit number. So our numerals, the 10 numerals, go from 0 to 9, right? Those are our 10 numerals, but we have a base 10 system. The language that we use in our base 10 system is based on the place value things are in. So I'm going to write a few of them out. They go on indefinitely in both directions. And I'm focusing mostly on what's on the right-hand side of the decimal place, right, the decimal point, because that's where the decimal part of it lies. So this is the tens place and the ones or units place. And then after the decimal, what happens is that we have places that start having THs on the end. This is the tenths place. And then we have the hundredths place. I feel like I need to have just a little bit more space. Let me move this up and change my pen. Then we have the thousandths place. And then there's the 10,000ths place. What do you think comes next? It's after 100,000ths. Okay, we're only going to write one more out. Do you know what the next one would be after 100,000ths? It's millionths. And the THS is really what's distinguishing it from what comes before the decimal. For example, we have the millions place on the left, we have the millionths place on the right, and so forth. And what we want to be able to do is we really want to be able to speak mathematically correct when we see a number. For example, it's all well and good when you say things like 32.4236, but it's not really mathematically correct, though we do it all the time, right? So we're going to practice a little bit in how we would write out numerals in words and or how we would potentially say them if we were speaking. So the 3-2 in front, we don't usually have any difficulty with. What did we do when we see the 3-2 in front? We say 32, right? That's not a problem. The decimal point is read as the word and. And this is one that will always be stuck in my mind because I had a second grade teacher that would harp on the fact that I liked to put the word and in the middle of whole numbers where it didn't belong, like 105. This is what I did when I was a kid, right? And it was a big deal to her that I pulled that and out of that statement because it wasn't right. And she's right, it wasn't right. The and actually means there's a decimal point. So when we get to the decimal point, we say and. What happens over here is that we're going to write this out, ignoring its location for the moment. So if we just had the number 4236, what would it say? 4,000. What's next? 200. And then what? 36. And then the last thing on there identifies the location where it ends. Where does that 4,236 end? In other words, up here, what is this final resting place value that the 6 is in? So can you count over and see what it is? It's 10,000ths, and that's what we write at the end of this phrase. 10,000ths. So if we were saying this statement or this number correctly, we would say 32 and 4,236 10,000ths. There's probably some commas we could throw in there that would make things a little bit more distinguishable. I'm not terribly concerned about that. I'm more concerned with how you would say it than I am about the punctuation you should use. So put some commas in there if it makes you feel a little bit more, like organized, but it's okay if they're not there too. Okay, is everything good? Okay, now we're going to go in the other direction. We're going to actually have one that's written out for us. So like something that would have been verbally conveyed. And then we're going to write it as a numeral. So this one says 536 and 76 thousandths. So the first thing you kind of might notice is that the and tells you where the decimal lies, right? And so we've got something that's before a decimal place and something that's after. So the 536 before, how will I write that? 536 before my decimal, right? That's 536. How do I write 76? Let's just look at the 76 part right now. 76. And this here tells us where it needs to end. Okay, how many places over do I have to go to get the thousandths place? How far? 3. So I need 3 places now here, and I need my 76 to end there, which means the 6 goes here and the 7 goes here. Okay? So what's going to go in that place where I didn't write anything? 0. A 0. Okay, so it's all well and good, like on the last one, when the numbers are actually in all the places, you don't have any zeros. It seems really very straightforward. It feels a little bit less settling when we have what seems to be a missing number. The missing number will occur as a 0. It'll show up as a 0 in whatever place it needs to in order to fill in the empty space. But you have to make sure that you're in the right place where it's ending first. Yeah.
Whatever you write, like what if it was 706? How would you write the empty space in the middle?
This piece right here would have said 706. So you would know how to write 706. It'd be 706. And then if it was thousands, you'd still end in the same place. Yeah. So that's kind of the key on that one. Yeah. Any other questions? Okay. Base 10 expanded form is a way of expressing each of our place value digits in its fractional view, kind of. So I'm going to actually write out, how many do I have here? 3 on each side. Okay, so we're going to build from this direction. This is the ones place. You all know that. This is the tens place, and this is the hundreds place. Everybody good so far? Okay. On the right-hand side, tenths place, written as a fraction, would be 1/10. Right, 1 over 10. This is the tenths place. The next one is the hundredths place, so that's 1 over 100. And the last one is the thousandths place, that's 1 over 1,000. Let me tell you what your book's going to do that I don't usually deviate from the book, but this is one place where I think it's really important not to do what they're doing, is that the book is going to change each of these into powers of 10. So they're going to make it look like this. Okay, so I'm going to write it, and then I'm going to mark a line through it. So if you write this down, I want you to make sure you mark the line through it that we don't want this, okay? It's always one of those weird things when you're teaching. You should never write something you don't want the students to actually do, and I'm breaking that rule, clearly, okay? Your book is going to tell you that 100 is 10 squared, which it is, that 10 is 10 to the 1, that 1 is 10 to the 0, that 1/10 is 10 to the negative 1, 100th is 10 to the negative 2, 1/100th, and 1/1000th is 10 to the negative 3. Those are correct statements. There's nothing wrong with them. The problem that I have with them from an educational perspective is that I feel like you lose the whole point of the place value. When you see the number 100, it has value to you because you know what 100 is. You know what 100 blocks is. You know what $100 is. You know what 100 is. If you see 10 squared, it abstracts it in a way that's not helpful. Does that make sense? So while your book is going to do this and it's going to have answers that are written like this, I don't want you to use them. Okay, this is a no. We're not going to do this. This is a big no. Because I want to make sure that you have this perspective of what these values actually mean. Okay, so that's my note at the bottom. Your book uses these negative exponents. We're not going to. So if you're taking a look at one like the next one where you're asked to write it in expanded form, what it means is you're going to take each place value and you're going to clearly identify how much it's worth. So like this 1 right here, what is that 1 worth? Because it's not worth 1. It's worth 100, so it's 1 100ths. You can think about like bills, right? Like it's a $1 bill. You can choose to write the 0. You could choose to skip it. I'm going to write it. There's 0, what? What is the place value that the 0's in? The tens place, so it's 0 tens. And then there's 3, what? 3 ones. And as we move to the other side, this one actually works really well to think about it in terms of money because it's 2 decimal places. There's 0 tenths, which would be equivalent to our dimes, right? And then there are 3 1/100ths, which would be our pennies. So this is expanded form. Again, what's your book going to do? Well, where it says 100, it's going to write 10 squared. And where it says 1, it's going to write 10 to the 0. And where it says 1 over 100, it's going to write 10 to the negative 2. Okay, so when you're checking your answer in the back of the book, please don't change it to that form. That's not what we want. Okay? All right. Decimal square grids are really good visuals for decimals. What these are is a 10 by 10 grid that represents our number. So we'll see if this is too thick. It's not too bad. So you're going to have a square, large square. You've got some space on there, right? It kind of as big as you can. And what we want to do is we want to draw in 10 rows and 10 columns. Okay, so think back to our area models, right? For fractions, it's like that. So we're going to draw this and try to do it as evenly as we sort of can. Feel free, if you don't like drawing freehand, to get some, grid paper or graph paper and make use of that too. I think that's 10. That's not too bad. And then we're going to do it vertically. Nope, that wasn't it. Okay, so I got 10 of them, 10 by 10 grid, right? And every one of those individual little blocks is a 1/100th of the size of the grid, right? The whole grid in this case is equal to 1. Like this is the number 1, okay? And it's split into 100 little boxes. So each little box here is worth 0.01 or 1/100th, if you prefer. Right? That's what each little box is worth in this particular picture. And what that allows us to do then is it allows us to take a number like this one, 0.24, and draw a grid. Feel free to just tell yourself on your next page to go back to the previous page and shade. I know I get to cheat because I can copy paste things. But this is our grid, and it's telling us that each box, we learned that each box is worth 1/100th. This number is 24 hundredths. So what am I going to do to represent 24 hundredths with this diagram? Yeah, I need to cover 24 of them. Now, technically, you can cover any 24 of them. But myself and the grader would like for you to have some sense in how you color this, please. So we're going to color one box straight down. That's 10 of them, 20 of them, and 4 more. Right? There's 24 of them are shaded. This is a visual representation of the decimal 24 hundredths. All right, so the next thing we're going to look at is how we think about fractions and decimals compared to one another. So there are some fractions that come out to nice decimals, and there are some fractions that don't, okay? So if we have a rational number, a over b, a fraction like the ones we were doing in chapter 6, and it's in simplest form, this is really important. People forget that part of this. It has to be in simplest form, right? No common denominator or no common factors, that kind of thing. Then this can be written as a terminating decimal if and only if the prime factorization contains only 2's and 5's. It doesn't mean it has to have both. It means it can't have anything else. So it can't have a 3, and it can't have a 7, and it can't have an 11. It can have 2's, it can have 5's, or it can have 2's and 5's. And if it can be broken down that way from the reduced fraction, then we will get a terminating decimal. Okay, so we're going to do some examples. This says mentally. Mentally is one of those tricky words because, yes, I'd love for your brain to be able to do it mentally, but I can't see inside your brain. So feel free to write down a little bit, but it needs to still be something that makes sense that your brain could do, okay? Not just that you would have to show it on paper. Mentally determine if the value represents a terminating decimal. If so, write it as a terminating decimal, okay? Now, technically, could you try to write it as a terminating decimal and then answer the first question? Yes, but then you aren't doing the directions, which was to mentally decide. Okay? So what was the first condition that this fraction has to be in for us to even check to see if this is going to work? Simplest form. Is 9 over 24 in simplest form? It's not. What do the top and the bottom both divide by? What's that? 3, yes. So the top and the bottom both divide by 3. So 9 divided by 3 is 3. 24 divided by 3 is 8. Cool. Okay. Is it in simplest form now? Yeah. Excellent. Now we can proceed. And this is the point when we can say, hey, let's check out that denominator. What numbers factor the denominator, like primes? If you broke it all the way down, what would you get? 2 times 2 times 2. Okay. Does the prime factorization include only 2s and or 5s? Yep, it does. So will this terminate? Will this terminate? Yes. So this is a terminating decimal. And that's actually the one you don't want it to be because now you have to do more work. If it terminates, it says you're going to find its terminating form. Now, you can, if you really want, go back to the 9 and the 24. But you're doing more work than is necessary because the numbers are bigger than they need to be. It's perfectly reasonable because this one's equivalent to it to do 3 and 8 and do the division that way. So you're going to do 3 divided by 8. And yes, you're really going to divide it. You're welcome to check with your calculator, but you're going to actually do it with the division on the paper. So how many times does the 8 go into 30? 3 times. What's 3 times 8? 24, and we subtract. What's 30 minus 24? 6, and then we put a 0 here and we bring it down. How many times does 8 go into 60? It is 7. What is 7 times 8? 56. Very good. We're almost done. We're going to bring another 0 down. Oops, I didn't do that just yet. Sorry. 60 minus 56. 4. Thank you. Okay, one more 0. If I bring a 0 down, I've got 40. How many times does 8 go into 40? 5. What's 8 times 5? 40. So if it terminates, you will eventually get a remainder of 0 and you stop. Okay? So if you keep going and keep going and keep going and you're not getting a remainder of 0 for long enough, right? I mean, it could be several steps, but if you're not getting a 0 eventually, you've either made a mistake or it wasn't terminating to start with. So you got to go back and take a look and see if there's something going on that you made a mistake with. And it could be something as simple as when you did 7 times 8, you wrote down 54 instead of 56, right? Like, so it could be something like that. So you can check your arithmetic as well as just the original factorization and so forth. Okay, next one, 10 over 24. What do I have to do first? Simplify. What will they both divide by? 2. 10 divided by 2 is 5. And 24 divided by 2? Wonderful. Okay, is that in simplest form? Yes. Now, if it weren't in simplest form, you just do it again, right? And you can keep doing this as many times as you need to get it there. 12. How does 12 factor? 3, and you might say 3 and 4, but then the 4 becomes the 2 and the 2. So at whatever level you need to see those pieces. Will this terminate? No. Why not? Right. So this one does not terminate. And I'm going to write it down, though it doesn't actually ask me to do this here. The reason is because it has 3 as a prime factor. And it's really important that you look at that with the reduced fraction. If we had factored 24, what would have happened? We would have gotten a 3, right? If we had factored 24 at the very beginning, before we reduced, we would have gotten a 3. And if we then used this theorem without doing the simplification stuff at the beginning, we would be led to think that it would not be able to be terminating, right? So you really do have to check and make sure that you have those finished, or those factored, simplified. Okay, so let's take a look at some comparing or ordering decimals. So we can compare and order decimals. We're going to line up the numbers by place value. So what I mean, and what typically works the easiest, is to stack them on top of each other because they're easier to compare. They're easier to line up all the tenths place and all the hundredths place and all the thousandths place if they're on top of each other. Make sure your sizes are approximately the same. You're not getting sort of led astray by your own handwriting or the size of things or whatever. We read the values from left to right, and we find the first difference. In other words, the first place where they are different. And then we compare the different digits. Okay, so we're going to do one. We have 4 numbers given, and they're given horizontally. That's typically how they'll show up when they're given to you. So the first thing we want to do is actually write them vertically, like stacked on top of each other. So I'm going to write 13, and then 4,919 10,000ths. And then I have 13, 492 thousandths. I have 13, and 49,183. Or am I 100 thousandths? Yes, 100 thousandths. And then the last one, let's see, 13 and 49,100. Did I get them right there? 199 10,000ths. Did I get them all in there right? I think so. Okay. Feel free to use lines to keep them straight. I'm thinking that, and I'm writing kind of sideways. That's from the previous class. Let's use a different color. Right, you could actually put them in a grid form like this, right, if it's help you to keep them straight, that kind of thing. It's kind of a mess on my screen, so I'm going to take them off, but this is something you could do. Okay, I do want us to compare, though, from left to right. So if I'm comparing from left to right, you probably should notice that the first digits are all the same. They all start out with a 1. That's kind of the height of unhelpful, so we just keep moving. Okay, the 1s are good. The 3s are also all the same. The 4s are all the same, and the 9s are all the same. So everything that's all the same does not actually give us any information. So when we get to the third decimal place, the thousandths place, we do have something that's different. The second number that's in my list has a 2 instead of a 1. Okay, this number would then be biggest. And you can feel free to add some zeros in if you wish. If it's bothering you that things don't line up because they're not the same length, you can add those zeros in. So if you would like to do that, you can. So this one's the largest, right? Because the 2 is bigger than the 1. So what that means is that I'm not even looking at this one anymore. It's been decided in the list of numbers where it falls. It's the last one. Okay? So we'll move on. The rest of them now all have a 1 in the next spot. After that, I've got 9, 8, and 9. One of them's different. The 9's different, right? I'm sorry, the 8's different. So at that point, these match. The 8 is different. And when I compare the 8 to the other 2 9s, it's smaller than the other 2, which means that this one's my smallest one. Now, it still could have been that, it could have been switched. I could have had 2 8s and a 9. That'd be fine. That means the 9 would be the biggest one next, right? It'd be the second biggest. But I actually found the smallest now. All right, our last digit, I am probably going to go ahead and write a 0 in here then so I can compare them. So I've already done this one. Don't need to talk about him anymore. And then our last digit is this 9 and this 0. All right, 9 and 0. 0 is smaller than 9, right? So this one right here would be my second smallest. And this one right here would be my second largest. So it asks me to write them from least to greatest. So I need to start with the smallest number. And my smallest number was this one right here. This was my first one. So my smallest number was 13 and 49,183 10,000ths. You can put a comma if you'd like. I'm going to actually put a less than sign because it is less than. But you can do a comment, it'll work. The second smallest, so this was my smallest. My second smallest is right here. It's the first one. It's the 13 and 4,919 10 thousandths. The second largest would be next. That's the last one listed. That's my 13 and 49,199 hundred thousandths. And then my fourth and largest one is the 13 and 492 thousandths. Okay? All right, last thing today before we take into groups real quick. It's a very quick one. Evangelical word for us right here. Christian word, we see the word tithe. It's in the Bible as well. Jesus talks to the Pharisees about giving a tenth of their spices and forgetting to do the more important aspects of the law, like having compassion and mercy. The tithe means what? It's an offering, but not just an offering. What kind of offering is it? Okay, money. It doesn't have to be money, but we use it that way now.
10%.
It's 10% specifically. Like there's a guaranteed actual number. So anytime somebody tells you I'm tithing 20%, no, they're not. That's not a tithe. The definition, like the word itself, means tenth. So a tithe is 10%. Okay, and I'm going to write it as 1/10 of something. Now, Aubrey's right. It is usually, especially the way that we use it in the evangelical church today, as a tenth of our income. And not just money, but like your income, like what you get paid, right? It's your income. In Jewish times, right, back in Bible times, they would do a tenth of lots of other things. Like the Bible talks about them giving a tenth of their spices. Can you imagine going to your spice jar? Here's the cinnamon jar, and measuring out 1/10 of the cinnamon jar and giving it to the church. Weird, right? Like that's not how we think of it, but that actually happened. So this is 1/10 of something. So what does this do with decimals? Well, in practice, it's like what you guys are saying. So in practice, we can take our income let's say you made $120. Okay, it's a random number, $120. And tithe is 1/10 of that, or 10%, which is what Faith said, 10%. What would be the tithe for $120? Be bold. Somebody give a guess. 12. It's 12. In particular, if you're looking at this and you're like, well, remind me what we do. The decimal's after the number 120, right? And you just move the decimal one place over. Or likewise, you could say divide by 10. So it's $12. This is what is meant by tithe.